So next, after stem and leaf plots, we're going to have dot plots. Maybe if it goes ahead, there we go. So your dot plots, what we do is we're going to have a number line, and then we plot a point above each value that is represented in our data. So a dot plot is a graph that can be used to give a rough impression of the shape of data. So it's kind of like a histogram. It is useful when the data set is not too large and when there are some repeated values. So if we don't have values repeating, this isn't the greatest. This one, stem and a leaf plot, is really good for data that doesn't have repeating values. Because you look through here, you know, like here in the 80s, there's oh, we're supposed to do that other way. 0, 2, 2, 3, 5, 8. So what we have is like, there's not a lot of values that we're repeating here. So when we go back to the dot plot, we do have values that repeat a lot. We see we have a lot of zeros here. So that's when we really like these dot plots. We want to consider the number of children a woman had, or sorry, number of children had that, number of children, it was a woman that had them, had by each president and their wife or wives. So what we do is we make a number line. So the smallest amount of children that somebody had, a president, was 0, and the most is going to be 15. So what we do is each time we get a 0, so our number line is going to be 1 to 15 or 1 to 16, whatever you need to do. Third time we have a 0, we make a plot. We got these two, so we made 2 points. Got another one, I make another point, another one, I make another point, another one, make another point, and then last one, make another point. And then we make sure when we go on to the next number, so we go on to these ones, that they do line up. Like I have a point here, so the next one should be here, so that everything should stay the same level. Because what we're basically doing is, this is just telling me frequency of different numbers. So I see that like 2, maybe 2 or 3 children is probably sort of the average, or 2, 3, and 4 is about what usually you expect that presidents are going to have. Now I have to look up which president had 15 kids because I don't remember now. Interpreting dot plots. So the dot plot gives a good indication of where the values are concentrated and where the gaps are. For example, it is immediately apparent that the most frequent number of children is 2, but only 4 presidents have more than 6. Ah, there it goes. That was where it was. So John Taylor holds the record for 15 kids. It is a lot of kids. So what we see here is that, yeah, past 6 kids is really unusual. We got a 7, an 8, a 10, a 15. 6 is still pretty common. Okay, so in this case, we're going to use that same data of the men and women, but we're going to make a dot plot. So to make a dot plot, first thing we need to do is we're going to put all this data together for a dot plot, just to point that out, so we're not separating it. So we're going to make a dot plot, oh, no, sorry, just heights of men, just heights of women, and then I'm going to try to show you what it is if we put them all together. So we'll put men here. We'll do each one of them here. So first thing you want to do is you want to make that number line. So we look once again at our smallest, and once again, this was women. And then we look at our largest data here. And I see my line's a little crooked. We'll just live with it. So I'm going to start at probably, instead of like 48, sometimes we'll pick something a little smaller, like maybe 46. So I have 46, and then we'll go up by like 2s. Just because it's really hard to fit every single dash on here. So we're just going to try to make it a little easier for ourselves. So I'm just going to go up by increments of 2. 62, not 70, 64, 66, 68. Then we'd have 70 and then 72. And that's as far as I need to go. And if you want to, you could put a little dasher in between them to indicate, there is another point there. So sorry, my scaling got a little off here. So we just put a little dot here. So there's my 48 inches. Then my 53. Then my 58. So this is probably not the best data to have done this with. And you'll see here in a bit why. The 60, 61, 64. Where was I? I lost on my place. 64. And then we have 65. 1, 2, 3. So one of them finally repeats. 67, 69, and then 71. So as you see here, this looks pretty uniform, except when we get to this one spot here. So where a stem and leaf plot made it really clear that around somewhere between 60 and 70 inches is where most women were sitting. This doesn't make it as clear that. Which is why I want to put all this data together here in a bit. Okay, so if I do the men now, the smallest I have is 57, so we'll start at 56, say. I'll go up to 58. There we go, 60. 62, so I'm just marking the twos again. 64, 66, 68, 70, 72, 74. Oops, let me do that again. 74, 75, 76. Almost there. 78, 80, but I need a little bit bigger, so I'm going to go up to 82. So I'll mark out those points again. 57, and then my 60, my 62, 64, 65, 66. We had another 66, and then we have a 67. I missed something. 68, 69, two 70s, a 72, a 73, 78, and an 81. Okay. So let me reconstruct this here a little bit so we can see it with everybody together. So like I was saying, with just the men, it's not a lot of repetition in there, so it's a little hard to see where the data clusters. So it's not always like I said, the best one for the spit out data. So if I add the women in here, hopefully it's going to look a little bit better. So we had that 48, that 52, we had a 58, and then we had a 60. So now we're getting some duplicates. A 61, we had a 64, we had more 65s, we had 1, 2, 3 more to add, 2, 3. Then we did have another 66 to add, a 67. We don't have a 68, but we do have a 69. We do have a 70, and then we do have a 71. So you see when you have more repetition in your data, then this makes it a little clearer what we're seeing here. So we got a few people down here, then it starts to like bulk up around here in the center, and then it peters out again. So it gives me a better overall view of what my data is doing.